So now we need our parser, and I'm just gonna that version I was kind of the Lexa, I was kind of based it on some stuff from GPT and my old version, a little bit of both. Um Now my parser, I'm gonna try and do essentially a one-to-one mapping of my old C# version. Probably the easiest way to make sure I get it right. And that version was kind of a little bit of a hack. But we're probably just gonna do it that way. It'll probably be the easiest. And at least it'll be right. It was pretty badly written, but as long as it does the job, that's the only thing that matters. So we're gonna need our constructor. What do we need? We'll pass our Lexa in here, I think. So it's gonna be a pointer, isn't it? Pass our Lexa in, and then we're gonna need a couple of functions essentially. Actually, we're gonna need a couple of things. We're gonna need, yeah, an array of tokens, and we're gonna need a position in that token stream. We're just gonna set that up. Now, we're gonna want a okay, let's start off. We're gonna need an advanced function. What that one does, it is indeed. Okay, so we'll just do this. We're then gonna need yeah, we're gonna want the peak function. We're gonna have token peak in offset. Is that the same? Now, we probably want a, is it just a min? STD min? In an unsigned lock. Can we just cast this? Okay. And we'll have a token priv and offset 0. Then I also want, I think, a peak is function, which will take to the string view symbol and offset. Yes. Okay. And two more functions or three more functions. Okay, we'll have a match to the string view symbol. This one. What's this one gonna do here for us? So if peak is sim, and now in my previous one, wait, well, my tokens are class, they were a record. Yeah, so if we peaked correctly and they match, we advance. return true, otherwise we return false. Then we had another match function, which was checking against the token type. So bool match token type. And this one was outputting token, yeah. So if it matches the type, actually, sorry, our out token equals peak. And if out token dot type matches, then we advance, return true, otherwise return false. And then there is another one. Which essentially took, I'll just show you guys this. I don't know how I do this in C++, varargs. Also, you can do std initializer list, I think. Let's say bool match std initializer list of token type. Just do this here, so we match this function instead. I did a similar thing in C#. Okay, so we have the majority of the functions we need. Where did that just go? Yeah, I'm gonna move this back over here. So essentially, these are all of our functions that we just need to actually even begin writing the parser. We're actually missing one more. Void expect. Let's see, stringus. Yeah, I'll just do that for now. Yeah, so now when we're parsing, we can't parse until we have some AST, essentially. So let's just make a file called AST. And essentially, just move this over here so you guys can see. These are what I have. Right, bring this over instead. These are what I have in C#. And we need essentially the same thing. So let's see. Let me see if I can do some multi-cursor magic here, just to really quickly convert these. Okay, so if I take these here, what we're gonna do is I think we can use a I think we can do it with structs. I guess we'll see. So now we'll have struct. we'll have this one that will replace this one here. Now all of these will be struct. I don't think I can multi-cursor all of these actually, so maybe it would have been better to just do them all from scratch. However, these ones here, let's make a placeholder struct here for value, which I will explain after. So what, we'll just take value here. Yep. Struct literal. Place some of those. Okay, so yeah, I'll struct literal. See if we can do this way. Variable. Binary expression. Fuck. Whoops. A function call. Assignment. So I'll explain some of these nodes real shortly. Maybe this part won't even be in the video because it, it's just a little bit tedious just replacing. Okay, now we get to our statement. So let's statement. Actually type it correctly. AST node. Okay, so what we got here? I wonder, I think there's got to be a better way for me to do these. Take that. Remove that. Put you there. And now what we got a name, we got an expression, condition. Else value. Almost there. Okay, so probably want to fix the naming on these, which is totally fine. Let's just quickly do that. Uh, it took way longer than I thought it would, so my bad. Needs to be done though. Am I going with camel case? Okay. Oh god. Then block, off block. So, in order for us to essentially convert our tokens that we had here into logic that we can execute, we need to use these AST nodes, which just store some information for us pretty much. So in our parser now, we will essentially store a list of a statement, which is essentially our program that we want to execute. So to actually process this, where do we begin? So let's create, well, first of all of this below, let's make that private. And essentially, yeah, we'll just have a parse function. I think we could do it that way. And then we'll have a okay, statement, yeah, parse statement function. And essentially then we'll just do, make sure we reset statements here. Statements, pushback, parse statement. Now in parse statement, it's going to be where we try and decide what that token is. So in our case, our first token here, it's a let statement, you know, for a variable. So we want to introduce variables into our program. So essentially now all we have to do here is if match, yeah, match let, then we'll have a, did this in, yeah, return parse let statement. Why did it complete like that? And we're gonna have a all parse, like let. Now we'll take our identifier, advanced.text. Yep, expecting equals. And then we'll need a parse expression, and then we'll return let statement. Correct. Which, yeah, takes the string name and then expression. So now we also need a parse expression function. Do we need constructors to be able to do that? Why does my tab do something weird? It's driving me nuts. Oh, what? Yeah, I don't know why that is. Okay. Anyway, a let statement. Let's move on to our parse expression. So this gets like really kind of complicated in a way because you need to deal with precedence, and I'm not going to try and explain precedence because I don't fully understand it myself, even though I kind of do. But essentially, we kind of need to, there's an order of operations that math can work in, and they need to be in the correct order, otherwise, the math doesn't add up correctly. Essentially, you know, like I can't give an exact case, but if you have like 1 plus 2 and then times by 10, you need to make sure, you probably want the 1 plus 2 to evaluate first, so we get the 3, and then we times 3 by 10, right? And then typically when you think about it, you'd like think of it like this in terms of math, right? Well, our code just needs to know that we need to execute the 1 plus 2 first. And even though this is just math, this works with like, similar concept applies with like calling a function in here instead, like get some number. Do you know what I mean? Like we just need to kind of make sure the precedence is there and it works correctly. So that's where it gets a little bit complicated, and the way I did it in my C# version was questionable, but I think it works. So we'll just kind of copy that and go with it, and you guys can also see and follow along whatever you're doing. Okay, so let's see. We need a few different functions, and I'm smoking a cigarette whilst I'm writing this code, so I apologize. So we're gonna start off with false assignment. I'm just gonna create myself a little bit of a template here so I can, because we're gonna need a few different functions. We're gonna have comparison into an add mul unary primary, and I believe that's it. So the way this works, we need to kind of like scaffold recursively, essentially. So we'll call parse expression, that'll call parse assignment, which will then call parse comparison, and keep going down the chain, until you've resulted in the correct expression. You'll kind of see. So let's start here, and what we'll do is, parse add. Oh, this is exactly the same as my C# code. That's hilarious. Although, is it? So parse comparison on mine. Nope, it's a little bit different. Let me. So yeah, parse comparison. We'll first try and parse around to get the left-hand side, and our right-hand side, if it's equal, or not equal, or greater than, greater equal, less equal, then it's an operation we want here. And then for the right-hand side, we'll call parse add again, essentially. And now here, Our expression will be, yeah, binary expression with our left-hand side, our up, and then our right-hand side. And I guess we need a constructor again. Slice an object type binary to expression. Oh yeah. That's actually a good point. I wanted to use structs just to make the whole parsing a little bit more lightweight, just as in theory to try it. But we're gonna run into issues very, very fast. So I think just to save myself the ball ache, an unnecessary ball ache, we're just gonna use classes. And we're then essentially gonna do STD shared pointer. And we'll essentially just use allocated objects. It is what it is. Okay, so std make shared. Now, okay, I guess in here now we have problem number 2. I'm gonna actually no, there's no point doing that. It's just kind of annoying having to change these. Wait. So we're gonna have to do that in a lot of other places, but we'll do that as we go, as we need to. Okay, so we cannot assign a binary because it's a shared pointer. Okay. You know what? I might just be dirty. I should use shared pointers. I might just use raw pointers. Now, there is a proper way to do it, but right now I don't really care too much about correctness and more about just code flow, you know, just coding. I'm just coding. I'm just doing my thing, you know. I'm jamming. We could do like casts and stuff, and now screw it. I've done this in the past in a previous thing I've made and then had to refactor all the shared pointers and everything else, but I'm just gonna go with it. Screw it. Plus it'll be a little bit easier to do these conversions as well. We just have to make sure to clean those objects up properly if we're like recreating the tree and everything else. So a binary is an expression, okay? So now, base class, oh, okay, so because they're classes, we now need these. And what's our other problem here? Cannot assign to type expression from binary base class is ambiguous or inaccessible. Why would that be? It's an expression. Is local type a local variable expression of binary? Oh, wait, no. What? It doesn't make any sense. Oh, wait. Oh, I know what I forgot to do. Okay, I see. Oops. I forgot you need this in C++. There we go. It probably would have worked with shared pointers now if I had that. It is what it is. Here we are. So, moving on. Parse add. So, very, very similar to the previous code. Let's see if... Yeah, plus minus advanced text. So parse mul. This should be, yep, unary. Handle star and slash. Parse unary. It's a minus or a plus. Now, in my other code, I essentially did this, and our left side was a new int literal. We're gonna need a constructor for this. Now, while we're here, we're gonna need a enum class value type, just as a placeholder for now. I'll have void in float vol string struct. Yep. And here we will need value type, right? And I think we'll have to do this for an untyped value. And we're now going to need a couple of other things, I guess. So yeah, let's take that constructor. And then we want a value of, so if we take an int in, okay, I don't know what that is. New int. Okay, I'm not sure how this is going to work. We'll try it. And then we'll do, yes, I think. And then we'll also have, wait, we'll do here in yeah, and then these ones we will just okay, I might be getting a little bit anal about my functions and stuff here, but we'll just go with that for now. That's as basic as we need, I think. And this should autocast, I think, for us. So yeah, new int literal converts it into a value holding an int, so that will work. our right side, then we fall into parse primary. Now parse primary is where we handle our ints and our strings and everything else. So yeah, this is already, we're basically AI coding right now, like full on. So if match token type number and okay, this makes me sad because I don't think in C++ you can't do this. Unfortunately. So I guess what we will do is what token number talk, and then return I wonder. Do it this way. Wait, we don't want to do it for an identifier. We want to do a boolean. Turn bool literal. And remove these braces, just clean them up a little bit. And then our next one is a string. And then we will match our identifier. Now this one, we have a few things to do here. We had a hacky way of doing field access. We'll leave that for now. We'll need to do function calls. So I'm copying my little dot block over here for that. And essentially, we want to match the left bracket. And yeah, capture the args. But we only want to capture the args if it's not a closing bracket, right? Is that right? Args add plus expression. Yep. Match the comma. And then we can return our new call expression here. So call expression, function name. That should allow us to handle that. Now what else have we got here? That'll allow us to do our print function. Let me see. In this case here, if we didn't match anything here, we're going to return new variable, which I'll need this for our primary top.text. Actually, yeah, no, that's right. And then down here, if we match an open bracket and we pass an expression, expect to close it, yep. So that does allow us to handle grouped expressions. A plus B plus, for example, like that. Otherwise, whoops. There are new. Okay, hold on. Let's see, can I use... Let this... Wait, I'll get ChatGPT to do this for me, just to make my life a little bit quicker for you guys and everything else. It's just code. Screenshot code this. Okay, so here, syntax exception, and then this function. And peak pause is pause. Tokens. Yeah, I'll be fine. Then down here, what was it? Row syntax exception? Oh yeah, it's just... And what was that? Unexpected. What can we do? STD format? Okay, so that's our expressions, but now where did I handle variables? Let me see. Oh yeah, we already handled those, right? Oh, we need to do this bit. So pass assignment. Yeah, so for now, this is probably correct. For now, that just calls pass assignment. I don't care about this. Pass let statement, return new let statement. There should be a pointer as well. By default, this is false in my other code. So pass that, blah, blah, blah. What else do we then do? Okay, so here we essentially fall back to an expression. Yeah, this has already got it here. Fall back to an expression statement and return that. called from function parse. I don't care about these. So now we go back into our main. So we got Alexa part. We'll
Which phone number, contact,
Alexa,
or device do you want to call?
Alexa, stop. That was fucking random. We'll call parse. Now, it'd be nice to be able to essentially dump the AST to be able to see what there is, but for now, let's just slap a breakpoint here and let's see what happens. Let's run this bad boy. Yeah, I don't know what happened. I went this one out. Unexpected token at position 32. What the hell is wrong with that formatting? Maybe GPT didn't do me a solid there. Primary token and the file. How am I doing this in my other code here? Okay. So there's our tokens and here's our statements. Okay, that doesn't look right. That does not look right at all. Statements, your okay, that's weird. Well, let's just step into the code and see what happens, I guess. So if we match, what are you doing again? Then peak is. We'll just call peak. We got a keyword token of let. Does that pass? It does. Pass let statement. Yeah, we got ident x. And if we pass our expression, and we get an int literal back. It returns us a let statement. Maybe it's just something with the debugger view. Yeah, not showing me the correct type, I guess. And it makes sense. Is there no way to really swear that normally doesn't do this? Strange. Well, we have a vector of statements regardless. Essentially now, let me see. Maybe what we'll do just so we can test things a little bit. We'll essentially just implement the O stream thing, I think. If I can remember how to do this. std O stream. Yeah, this. Find O stream. Don't know if we can make those virtual. Okay. I wonder if it will essentially allow us to overload. So we're not using that. We'll want to do the variable one. Binary expression. Assignment we might need. Have S statement yet, break, continue, block for type. Okay. And then I think in here, I believe we can just do this. If that's right. Yeah. Do I need to dereference it? We just end up with statements. I think I've done something wrong here and I don't know what. Because I swear these should be of the correct type. Hmm. Okay, so I think I know I did wrong. I've run into this in the past as well. I'm just doing a little bit of testing. I believe we actually need a essentially a virtual print function, and we pass in this virtual void print, and then like here, for example, do this instead and remove that. Oh my god. So I will be back in a minute and I'll just replace all of these. Okay, Yes. So that version works. We can now fucking debug it correctly, and we can see here our AST. Now, our next stage would be to omit the code gen for the instructions, basically, so we can actually, turn this into something that's executable. Right now, we just kind of know that what our code is and what it represents. But I've also just noticed something here is potentially very wrong, unless it's just the formatting, which it could be. I think it might be. So yeah, we'll move on with that part, and we'll begin emitting the code gen, so we can actually begin making it process something. I'll be back.